For today's webinar, we're joined by our partners SageNet, who offer cybersecurity, consultative, and managed services. The topic for today's webinar is going to be on secure remote access. Specifically, we're going to get a little technical and break down the differences between how a VPN is architected and operates versus how a software-defined perimeter is architected and operates. So our presenters for today are Neil Christie. He is the Director of Cybersecurity Solutions Architecture at SageNet. Neil has been with SageNet for over 5 years, but has been in the cybersecurity industry for over 20 years, working across banking, healthcare, energy, and retail sectors. He's been a certified information systems security professional since 2004, which makes him pretty well suited for today's technical conversation. And from Appgate, we have Jim Anthony, who's the VP of Cybersecurity and oversees our enterprise sales engineering team. Jim's going to be taking the lead in today's technical demo and has over 30 years of experience in cybersecurity. He owned his own consulting company and has been with Appgate for over 6 years. So with that, Neil and Jim, the floor is yours.
All right, thank you. And thanks everybody for joining in today. I'm excited to be here. We've got some interesting content. We're going to, try and show you and hopefully demonstrate to you how VPN technologies are becoming last year's news and what the new news looks like. So moving into the news here, really I don't want to spend a lot of time from a fear, uncertainty, and doubt perspective, but the reality is one thing that we can likely all agree is that remote work is here to stay. And VPN technologies are something that's been around way too long. So, and interestingly enough, if you can just click forward one time, some news actually coming out this week that we're all likely aware of is that FireEye, their red team, was attacked and breached recently. And a lot of their red team tools were exposed and now are being potentially used by nefarious folks. Some are saying Russians. We're not all entirely sure at this point. But as you see those highlights, a little bit small on the screen, but suffice it to say those are specific to VPN technologies that have had recent CVEs that are being targeted as sort of that living off the land. Even though they've been out there for a while, they are still being utilized in the wild. So some really relevant stuff here. So moving on to the next slide. How it's relevant to what I do on a day-to-day basis and why you might want to listen to what we have to say is not only my experience from a long time in the industry, but at the SageNet Cybersecurity Division, we do manage services around these things that have to take those indicators of compromise as an example and bake those into our SOC services so that our analysts are understanding how our customers are potentially being attacked. Vulnerability scanning, looking for those CVEs that are specific to those attacks are now becoming a higher priority. And actually, most interestingly, penetration testing business, right? We've been seeing this VPN problem, and it has been a target for a long time for us, and is always a threat vector that we tend to find either a vulnerability or some sort of weak password or authentication strategy associated with it. So I don't want to spend a whole lot of time on this, just suffice it to say we do a lot of stuff in the cyber business. So moving on to the next slide, from a pen testing perspective, these are the things that we see. Amazingly enough, many of the organizations that we work with are still using just username and password for authenticating to a VPN. Hard to believe since two-factor authentication has been out there for a long time, but this is a reality. And their internal domains are just using a default complexity, which is, if I were to throw out winter 2020 with a capitalized W and a bang on the end, likely somebody in your organization has that password right now. Just crazy, and that hits the complexity requirements from Microsoft. So a little tidbit for you to take back to your organization to put down your security awareness. But and then VPN portals are easy to identify, right? It's usually VPN whatever your company name is .com, right? Or it may obfuscate the port from 443 to 444. Not really hard to enumerate and really figure out, essentially just from header information, what type of VPN it is even. And then you start getting into versioning and all those things. So the hybrid cloud environments are, everybody's got some level of cloud at this point, if not fully cloud, but there's software as a service. How do you keep all that squared away in a secure way that you can lock that down? VPNs are having a hard time with this. It's a traditional security solution that just isn't capable. VPN technologies are not being updated. This is a classic conundrum in IT, that to keep things, up to date is just nearly impossible, and something that has the single point of exposure even still has problems, especially now with everybody working remote. Nobody wants that thing to go down or have any issues. And then they don't all have posture checking and limited control capabilities as you connect to those. Should they have access to the whole network? Likely not. Do they need it? Definitely not. So moving on from there, that's kind of the way we see it from a pen tester's perspective. But I know you guys the name of it is called Hack the VPN. And as I dug into this idea of whether I would show you a live hack, this sort of scared feeling came over me. And when I looked at what actually happened in Black Hat in 2019, this is what I found. It took almost the full hour to go through the hacking components of what this presentation entailed. So I have 10 minutes, so I got to hurry up. So anyway, this group in 2019 identified an AnyConnect 0 day within their research at DevCore, this organization that sponsored this talk. They did the responsible thing, disclosed it to Cisco to fix it. That Cisco patched it in accordance to what they should do, which is great. And within a month, well, at the end of that month, which is typically what a critical vulnerability gets within an organization policy-wise to patch, they gave Twitter that time and found that it still was not patched within a month. Now, I'm sure none of us have a critical vulnerability that hasn't been patched in over a month, but it can happen and will likely happen again. So, the reality is our VPNs are under attack because of this remote work situation, and it can be successful with just enough concerted effort. So the next slide is, what do we do about it, right? At this point, we're semi-stuck with what we have potentially if our budgets are tight, what have you. So, the reality is we can do the software updates. That is something that will still keep at least the known vulnerabilities at bay. Look at machine certificates if you want to make sure these remote machines are part of your domain or they're known authorized. And then, of course, two-factor authentication. I can't say that enough. And then making sure that those logging elements are coming to your SIM so you can alert on interesting activity. But this is 4 bullet points that can be complex at times to keep up on. And the reality is AppGate is here to show us how this SDP alternative can help fix some of these problems. And I'll hand it over to Jim here at this point to kind of dive into that element of the presentation.
Hey, Neil, thanks for that preamble. It's interesting. We started putting this webinar together a couple of months ago and started thinking about what we were going to present and how we were going to do it. And we would have never predicted that on the week that we're going to deliver it, that FireEye would be compromised. And Cisco also on Monday of this week announced a new CVE for their Cisco AnyConnect product. So, I mean, it's just relentless, right? The VPNs they're fraught with all these issues. And, on the screen, what I'm really trying to expose is sort of summarizing some of those issues around the VPN. You can read them on your own, but let me just give you the lay of the land to kind of what we're really here to talk about. VPNs are limited in what they can do. They're built on old-fashioned technology. They have open listening ports on the public internet, as Neil mentioned. These ports can be found, they can be compromised, and there's lots of ways to do it. On top of that, VPNs are notorious for having single tunnels. And if you don't think about the capabilities of multiple tunnels, this single tunnel doesn't seem like a limitation. But the reality of it is, what it forces you to do is every single user needs to access your entire environment, no matter how big, no matter how complex, through that single VPN tunnel. That's going to force you to have more bandwidth into that location, reliance on a single piece of equipment to terminate that VPN connection, the idea that you've got to now provide end user connectivity between your data centers, which is a disaster if any one of the data centers becomes compromised. And then beyond all of that, the VPN doesn't do anything to limit your access within the environment once you've authenticated to it. So these are all issues with the VPN that software-defined perimeter resolves. And so without further ado, I've made all kinds of sacrifices to the demo gods this morning, trying to make sure that we're able to give this demo. This is going to be live. There's nothing canned about it. And so, things may go bump as I try to go through this, but let's step through a couple of scenarios of really what a VPN is like and what the difference is on the AppGate side with the software-defined perimeter. I'm going to use a little demo environment that I built on Amazon, for example. In this environment, I've got a data center in the east. Literally, it's the AWS Ohio region that I'm going to be leveraging. That's what I'm calling DC East. I'm a user, and I'm the user on the left on the screen. I've got various clients running on my machine, whether it's an AppGate client or a Cisco client. I've got those software technologies installed locally, ready to rock and roll. And within that Amazon environment, I've got a subnet. It's 10.0.202.0/24, as you can see on the screen there. And then within that subnet, there are several machines, virtual machines, that are running some basic cloud services. Some of those machines I should have access to as an employee of this environment, and others I should not. And we're going to show what this kind of looks like within these various scenarios. So the first thing that I want to talk about is what's exposed to the outside world. These environments are they're in a data center, whether it's a cloud data center or a physical data center or a colo facility. It kind of doesn't matter. From a network perspective, they all look the same. There are termination points on that network that I need to try to reach to, and how do I reach to them is really the key. Well, there's open ports on that VPN concentrator. For example, if I need to SSH into that VPN concentrator to make a config change, I'm going to need access to port 22. So port 22 is open, exposed to the public. There's also a web console for that VPN concentrator, and I might need to browse to that web portal to actually do some sort of login and configuration change as well for that. And then, of course, port 443 is always used unless you obfuscate it by trying to move it to a different port, but you need at least some port to answer the end user requests that are using the clients to actually access that environment. These are 3 open ports at a minimum that are almost always included with a VPN concentrator, which means they're exposed to the outside world, they're findable, they're attackable, and that's the bottom line. On the AppGate side, there are no open ports, right? So all open ports are closed to unauthorized access. Unless you're a preordained authorized user to reach that AppGate environment, those ports are not going to be open for you. And we're leveraging something built into AppGate called single packet authorization to achieve this. The idea around single packet authorization, or SPA for short, is that you as a customer get to define your own SPA token. It's unique to you. You get to decide how long it lives, when do I rotate it, when do I change it, how do I distribute new ones. But the point is, it's not shared with any other customer. And this SPA token is what enables your AppGate appliances to communicate with your users when they attempt to log in and authenticate. So let's prove it. I'm going to Alt-Tab over to a couple of other windows. So the first thing I'm going to do is go to my terminal windows here. Within my terminal windows, I've got 2. You can see one layered on top of each other. Oddly enough, they're different colors, and I did that on purpose. If you know Cisco, and I'm just picking on Cisco in this instance because they have VPN concentrators that you can download into your cloud environment, makes it relatively easy to deploy. So I'm picking on the Cisco AnyConnect virtual appliance, the CSR 1000V. I'm representing all activity into that CSR 1000V through this blue background, green text, sort of a Cisco-ish color scheme. On the other window, I've actually got a black background, orange text, sort of representing the AppGate color scheme. So all things relating to the AppGate entry point in the AppGate world, I'll do in this window, sort of to keep things separate and keep it clear in your mind as to which solution is in play. The next thing that I want to point out is that prior to the webinar this morning, I did a port scan on the IP addresses of both entry points. So on the edge of that network is a VPN concentrator as well as an AppGate appliance. So I did a port scan on both of those appliances from port 1 all the way to port 1024, just looking for open ports. And as I scroll back up here, you can see that there's no open ports. I can go all the way to the very beginning if you are patient enough to allow me to do that. And you can see that the output is pretty common, pretty similar all the way up. There's no open ports all the way to the very beginning. On the other hand, if I flip over to the Cisco side and start scrolling up, I'll pause whenever the screen changes. for output. So you can see as I get close to 443, I'll slow down. Port 443 is actually open. So you see success right there on port 443. Scrolling up, I'll get to port 80 would be next sequentially as I go backwards. So as I get to port 80, you see it's also open, right? And then obviously port 22 was the last one that I mentioned as the preamble here. So port 22 is open. And just to prove that I'm not doing anything nefarious, let's run that port scan again and relook at those ports. There's 22, there's 80, and there's 443, all successful still. So that IP address is the IP address of my Cisco concentrator that's waiting for a VPN client to connect to it. That means these ports are exposed. Let's flip over to the AppGate side and run that same port scan in real time. So here's 80, operation timed out. Here's 22, again, operation timed out. And here's 443, again, operation timed out, which means I'm not connected using my AppGate client. I haven't presented this single packet authorization token. So that appliance is literally ignoring me on all fronts, right? It's ignoring all traffic because I'm an unknown, unauthorized user at this point. So again, I think that's the very first thing that I wanted to prove to you guys is that, you know, I've showed you on the VPN side, I've gone in and done a port scan on this 3.18.201.145. I found 3 open ports. Those open ports are compromisable. 22, 80, and 443. Now that I know that there are open ports, I have a way of determining what operating system is running behind them, what services are listening, and if I'm a real hacker, I'm figuring out exactly how to compromise those ports. On the AppGate side, I did the scan on 3.136.107.88. Again, no open ports were found. There's no way for me to even have an attack vector into the environment. So the entire entry point is obfuscated. Think of it as the front door has been turned into a virtual brick wall. And that's really what we accomplished using single packet authorization and AppGate, software-defined perimeter. All right, so let's move on to the second scenario. So what I'm going to do in this scenario is actually authenticate with each one of the clients. So we're going to authenticate against the VPN, and then I'm going to determine what I can see, right? Then I'll disconnect that particular client and authenticate against the AppGate environment, and then we'll run another scan and see what I can see on that network. If everything works out the way it's supposed to, when I connect with the VPN, because it can't limit or control what I can do on the other side of that VPN concentrator, I should have unlimited access to every server in the environment. So just to keep things simple, I'll run a port scan on TCP port 80 just to prove that I can connect to those particular servers that are out there. On the AppGate side, I'll connect in, but I've got the ability with AppGate to limit who or what servers you can have access to based on a lot of different information. In this case, I'm going to use metadata about those instances. So I am only going to be granted access to active instances within the environment. So let's prove it. So the first thing I'll do is flip back over to my terminal window and activate my Cisco AnyConnect client. So let's show that window. There it is, 3.18.201.145. Let's hit the old connect button. And of course, I get a certificate warning because I didn't go buy a cert for it. Here's some credentials. As Neil pointed out, no multi-factor. I could certainly enable multi-factor if I needed to, and I could do the same thing on the AppGate side, but this is a simple connection. I'm now authenticated, logged in. Again, I can go back in and show the statistics window. I've got a tunnel. I'm connected to that particular destination. Let's see what I can find on the network. So I've built a little shell script called a netcat range scan, and I'm scanning that 10.0.100 network, starting with .3 and ending on .14. Let's see what comes back as a success when I run that port scan. And so that's out running against that AWS environment, and it should not have taken that long. So hang on just a second. All right, so it ran a scan on 12 IP addresses and the 10.0.100 subnet, starting with .3 and .14, and actually 0 came back as successful. And that's because 10.0.202, oh, I ran the subnet scan on the wrong subnet. It's 202 that's actually in Ohio. And so let's run that again and see what that looks like. So, there it is. So 10.0.202, starting with .3, ending with .14. And it came back, it found a successful connection on port 80. In fact, it determined that there's an Apache 2.4.46 service listening with PHP 7.2.33. If I'm a hacker, I pull out my handy dandy guide. I now know what I can hack into, right? I know what services are listening. I know what versions are there. And if I haven't patched it in a while, it might be exploitable by some sort of nefarious activity. Point is, I can see port 80 on .4, .5, .6. Every single IP address within that range is exposed to me through that VPN concentrator. Not really a great situation. So let's disconnect the VPN and connect over on the AppGate side. So there I'm disconnected on the VPN. Let's connect on the AppGate. See, the demo gods almost got me, but that was my own mistake, scanning the wrong subnet. Neil's laughing at me. So here we are connecting in with AppGate. I've now connected. Disregard what you see on the screen here. I'll explain that in just a second in the third scenario. But let's run that port scan over here. Let me find my 10.0. See, I'm not going to make the same mistake. Here's 202. I'm starting in 3 and .3, and I'm going to end on .14. Let's see what it comes back with on the AppGate side. So it successfully found a .5, a .7, a .9, a .11, and a .13. Well, that's interesting. So remember I said that I was going to grant access based on this metadata concept of mode being active. Well, let's go look at that AWS console and see what that actually looks like. So here's my web.9 server, and it is in fact a mode equal active server. .8 is mode equal QA, and so on down the line. So you see I've set this environment up so that my odd IP addressed servers are actually active. My even IP address servers are actually in QA mode, and you can validate the IP addresses out here in this column. So I think I've proven it that as I've connected in with the VPN concentrator, I was actually able to access all the instances that are running on the other side of that concentrator. That port scan proved it, specifically on TCP port 80, which is what I set that scan up to look for. Once I connected in on the AppGate side, I was only able to see those active servers, in this case, the oddly numbered IP addresses associated with that subnet. Again, only port 80 is what I looked for. There may be other ports out there, but the point is that AppGate is controlling that I can actually see only the active servers because of the entitlements that it served to me. And so that's proof point number 2. Let's flip to number 3. Now let's get a little bit more real world. I've got multiple data centers, right? I've got a physical data center. I've got some cloud environments. I might have a colo facility. Well, now what do I do, right? Well, with a VPN and multiple data centers, I've got a couple of options. I could absolutely deploy another concentrator, right? I could teach my end users that when you connect to certain applications, you got to be on this VPN, and when you connect to other applications, you got to be on this other VPN. You know, that's an interesting concept. I got to pay for additional licenses. You know, I've got another box to manage. Back to Neil's point, I've got to worry about patching that thing just like I patched my first one. There's lots of things that I got to deal with, but the worst thing is that I actually have to put the power into the hands of my users so that they know what they need to connect to. That's going to create nothing but confusion, right? All right, so that's a bad idea. Well, I got another idea. So again, with a VPN, I could establish a LAN-to-LAN connection, right? So now I've actually got to buy 2 additional VPN concentrators, or maybe leverage the existing one that I already have and provide that connectivity across. But the point is, I now have a more complex environment. I've got to manage and deploy all those VPN concentrators. I've got to predict that required bandwidth that's connecting me from the corporate facility off to that cloud facility or to that secondary data center. I might even have to figure out how to predict the type of traffic that needs to flow between those destinations. If I can't predict it, I need to just open it wide up so that I don't interfere with an end user's ability to traverse that LAN-to-LAN connection. That's going to lead to compromises. If one data center gets compromised, then the other one will get compromised. So how do we do this with AppGate? Well, with AppGate, it's pretty simple. We can use the centralized console to configure a second site. We deploy additional gateways to that second site, and then we serve entitlements to that second site. And so let's show you that. It allows the user to connect simultaneously to both sides. So if I flip back over to my command prompt, and remember I said, disregard this, I'll explain it in a minute. I've actually already done that with the AppGate solution. I've got a data center not only in Ohio in East, but I've also got one in Northern California that I've granted the user access to. And again, same scenario, within that facility, he should only have access to those instances that are tagged mode equal active. And so now I get to the mistake I made in the first scan. I can now scan that 100 range, because that's the IP subnet that's sitting out in Northern California, and figure out exactly what this user has access to while connected to AppGate. And so 10.5 or 100.5, 100.7, .9, .11, and .13, same scenario, odd numbered IP addresses. If I flip over to my AWS environment and change to Northern California, you will see that within that environment, I have the same setup, allowing instances with the oddly numbered IP addresses being mode equal active, and the even numbered IP addresses are mode equal dev. You can see the IP addresses there. And so I didn't bother to deploy additional VPN concentrators. I didn't bother to establish a LAN-to-LAN tunnel, because it's just completely unrealistic to do that for this type of demo. So what I think I've proven to you here, though, is that, you know, under the traditional VPN scenario, I could either deploy another VPN concentrator, teach my users how to connect to it and when to connect to it under the right circumstances. Or I could have gone and done a LAN-to-LAN scenario. I've got extra concentrators, extra costs, I've got latency and things like that that might be introduced. For example, if this user is actually sitting in, say, San Diego, and he's got to connect back to Ohio, and then Ohio provides a connection to AWS Northern California, that's a bad scenario. I'm crossing the country twice when all I've really got to do is go up the coastline to get to that facility. On the AppGate side, I've got simultaneous tunnels. The same access control mechanism is allowed. The same types of policy enforcement is allowed. Mode equal active in this particular scenario. It could literally be anything that you dream of as to how you define exactly what a user is allowed to have access to. But the point here is the end user doesn't have to know or worry about where those apps are deployed or how they get to them, which one to connect to. If they're granted access to it, they get connected to it automatically. Same username, same login, same client, same session. So key takeaways from these three different demonstrations. First thing to remember is that your end users, despite what they might or might not tell you, they hate their VPN client. That thing is a pain. It crashes, it provides limited bandwidth, and it is literally the bane of their existence when they're trying to get work done and they're trying to, you know, hurriedly get into the environment to reach those things that they need access to. Key takeaway number two, VPNs are making your businesses more vulnerable to outsiders, outside hackers. These open listening ports are a key problem because you're making it easy for your end users to access that VPN by registering DNS names associated with those VPN concentrators. It makes it even more easy for hackers to find those open ports. Okay, takeaway number three, VPNs are creating more opportunistic environments for the insiders to be nefarious. They're not limiting what the end user can do inside the protected network. So that end user is free to move laterally. If those credentials get compromised and a bad guy actually successfully authenticates to your VPN concentrator, now your bad guy has the ability to move laterally. And if you're connecting multiple data centers with the LAN-to-LAN combination, now you've got a really bad scenario where any system in any of your data centers could be compromised because of this. AppGate has a whole lot of other features that we haven't even really talked about, including, I've mentioned single packet authorization and multi-tunneling, but we also use session-based micro firewalls. We can do posture checking and ring fencing for the end user's devices themselves. We have a very broad protocol support that doesn't include the use of any proxies. I've demonstrated a little bit of these auto resolvers around metadata, and I can dive deeper on that if you're interested in seeing that in a future session. And then finally, the ability to use API calls and deploy AppGate as code is actually something that a lot of our customers take advantage of. And so if you're interested in what you've seen and the message from Neil and SageNet resonates, I would encourage you to go take a look at our test drive environment. So we've got a AppGate solution deployed It's publicly available. You can access it through the URL on the screen, partner.appgate-sdp.com. Be sure and put SageNet in the referrer field, and that way we can track your interest in AppGate back to SageNet. And without further ado, Neil, any closing words or comments besides thank you for attending the webinar?
Well, it just comes to mind early in my career of cybersecurity, one of the tenets they always talked about was micro-segmentation. And this, that was impossible in the traditional sense of putting firewalls everywhere, right? Physical firewalls is what we used to deal with. It dates me a little bit, but this technology puts us in a position to make that tenet of security a possibility. Not that it happens overnight in an organization. It's always going to be a use case by use case, and VPN is one of those use cases. But imagine a day, no matter where you were connected within your network, whether it's internal, external, your users only had access to what they needed, not full IP stack. It's just amazing. Thank you for everything. Thanks for everybody joining in. This is always fun to talk about.
Excellent. Thank you, Neil. We do have a couple of questions that have come in. Questions about recordings, things like that. Yes, we're going to make a recording available, so we'll send that link out as soon as it's ready. I think, as George mentioned at the very top of the call, that'll be available tomorrow. Another question has come in: does AppGate support SAML 2.0 integration with SSO providers? The answer is absolutely yes. We've got customers that use Ping Identity, Azure AD, Okta Duo, Jump Cloud, so even some that you may or may not have heard of, but absolutely any SAML, LDAP, or Radius-based provider we can integrate directly with. We talked about, there's another question that came in around gateway scaling. Is there an as-a-service option for the controller? And so the managed gateways, other than on-prem or infrastructure as a service of the controller managed by AppGate. The answer there is yes. We do offer AppGate as a managed platform as well. It's optional, it's not required. You can manage it yourself if you choose to do that. But we do offer AppGate as a managed service. It's an interesting architectural change or difference that you can think about. If it seems like it's a little more complex than you want to deal with, or you want us to be responsible for making sure that those devices are safe and secured and locked down, we're absolutely on board with that. A couple more. I'm reading in real time these questions, so keep in mind that there's some really long ones in here as well. So the added security seems to make considerable, or it makes sense under certain circumstances. Considerable undertaking, move away from incorrect network policies, etc. Yeah, so AppGate can be implemented in a simplistic way. Think of those applications that I defined as individual web servers based on that metadata. It doesn't have to be that tight, that restrictive. It could actually be an entire subnet. In that scenario, you can capture traffic and see where people are going within the network under a window of time, and then ratchet down that security a little bit later as you get used to the environment and how it really works. I got some kudos for the demo itself. How do we ensure privacy, and what about logs with foreign governments and things like that? That's a good question. All AppGate activity, all activity generated by your AppGate users, the clients and the gateways and appliances that are out there, everything is logged. There's no doubt about it. But remember, this is delivered as software to an entity, to a customer. That software remains yours. It's configured by you. It's configured the way you want it to be configured, and the log records are yours as well. So those log records can be kept within the AppGate environment. They can be fed to your SIM. They are not captured and collected by AppGate as a service or some other entity and made available to you. They're captured by your environment, by your solution, so they're private to you. There's a question around
one other thing there, Jim, on our managed services. When we get into a converged AppGate customer as well as a SIM SOC as a service, we do consult in that way that says, here's the posturing that you should do. Really, the heavy lifting on AppGate, honestly, is on the policy generation at the beginning, and then once you're kind of set as to the way things work, it tends to be relatively easy to manage, unless you're progressing your use cases. Of course, that can be a little, but that's more project based. But then the integration of those logs, integration to SIM, Splunk is an example that we've done in the past. We have other platforms that it can work with, and relevant information that can be helpful to provide any compliance requirements or any monitoring requirements necessary.
Yep, that's thanks for picking that up for me, Neil. Questions around various certifications have popped in as well. I will tell you that AppGate is we're a big player in the Fed space, in the DoD in particular, and so we are common criteria certified. We don't offer managed AppGate to the Fed space just yet. We will have to get some additional certifications to do that, but suffice it to say that when the Fed wants to manage their own platform, that AppGate is certified for the Fed to consume AppGate in that way. We can be FIPS compliant as well. It's an option that you can enable in the product, and so that's another compliance that we've got. Smallest customer, usually a smallest customer that we deal with is around 50 users. Biggest customer, tens of thousands, hundreds of thousands of users. So anywhere in that range, AppGate is a good solid fit. AppGate, how does AppGate mix in with the cloud? Specifically, AWS was asked about, but this answer applies to GCP and Azure as well. We are in those cloud marketplaces, so our AppGate appliances are actually already in the marketplace. If you'd like to do a test drive, there's a free 15-day test drive in the AWS marketplace. You can download AppGate, test drive it in your own environment. There's installation instructions and things like that are included. We can also support AppGate running on other cloud platforms, such as Oracle Cloud, Alibaba, IBM Cloud. Most all of those cloud platforms are built on industry standard hypervisors, and we support just about every hypervisor you can think of, including OpenStack, KVM, Citrix Zen, VMware, Oracle Box. There's probably others I'm not thinking of, but just about all of them that are out there we do support. There's questions around cost efficiency for small businesses and reporting as well. And so, yeah, AppGate we're seeing a high adoption rate, especially with our AppGate as a service model. So we can actually, as Neil mentioned, we can actually work with you to manage the AppGate environment on your behalf, make it very simple to deploy and manage into the future. The pricing model is built around end users, numbers of end users, and so it makes it really easy to understand exactly how it's priced and digested, if you will, from a pricing perspective. A couple of more questions. HIPAA compliance is a big question. I would say that, and I think I answered the licensing questions that are remaining. So this will be the last question. We are looking at, there's all kinds of different compliance questions that pop out. HIPAA is just one of them. PCI is another one, and Neil can help address that as well. Here's the thing how we usually stay focused on compliance type questions. Software such as AppGate doesn't in and of itself guarantee HIPAA compliance. It doesn't in and of itself guarantee PCI compliance. It's all those processes and the way that you architect that deployment that really help ensure the compliance levels. And so absolutely 100% AppGate can be part of a compliant deployment, whether it's PCI, HIPAA, or other compliance. And so, we've got customers that use our product to achieve those levels of compliancy. Neil, anything to add around compliance?
Sure, yeah, we're specific around a lot of retail customers and are using this for the use case to connect to devices within the cardholder data environment. And that's when it becomes a connected device as they define it in the PCI world. And at that point, it has to prove some level of compliance, whether it has antivirus running, whether it has patch status in a reasonable state, whether it has file integrity agent installed. Those sorts of things can all be defined in that posture checking and then audited to the level of it's a report that's generated on a monthly basis that shows this, or daily basis, however you want to configure it. Or you can have things in that SIM integration that you talk about, where the use case is if anybody does connect without it, or you can enforce to not allow them in. It's just sort of there's all kinds of options within there that help to satisfy however you want to implement that.
Perfect. With that, we're going to close it down. I will. I'll remind you, partner.appgate-sdp.com if you'd like to run a test drive, experience AppGate for yourself. Make sure you put SageNet in as the referrer. And thank you for taking a little time out of your day to jump on this webinar with us. And we look forward to a follow-up conversation. If you're interested, feel free to reach out. Thank you.